Alrighty, folks, here we are with our Chapter 9 review. We're going to do number 25 and 20, not 25 and 29, 25 and 31. So we're going to start out with number 25 here. We are simplifying the complex fraction. So when I look at this problem, I am typically going to look for what I need to get all of my fractions on the bottom into one big fraction and all of my fractions on the top into one big fraction. I do notice a little thing going on right here, though, which is I see this is 3 and then x minus 15. I would kind of like to see this look like 5 minus x if possible. And this is just, I don't know, like a math intuition thing. I don't know. I just see this and it jumps out to me as maybe a possibility. So I want to see, how does 5 minus x possibly relate to 3x minus 15? Now there we go. We got a genius in the room. We are going to divide here by -3. If I factor out a -3, I should have said factor, not divide, but if I factor out a -3 and I swap the position of these two things, so one, I guess first step I would have done is I would have written -15 and I would have wrote plus 3x. And now I'm factoring out a -3. So I'm factoring out a -3 from the 15 gives me a positive 5. Factoring out a -3 from the 3x gives me a -x. I'm going to try and make this look more like a parenthesis, less like a line. There we go. So now, as I look at this thing, we're going to let Josie in. Welcome, Josie. And now as I look at this thing, I'm saying, okay, well, I got -3 times, and then I got 5 minus x, which is the same on the thing on the left and the thing on the top. So it's going to be advantageous for me. One thing I could do is just go through and nix the 5 minus x from everything, but I won't do that. Instead, I'll show you how I would add these things together. So I'm going to rewrite what we've got on the bottom here. So instead, I'm going to call this -3 times 5 minus x. And then I'm saying, okay, well, what is needed to make this thing on the left look like this thing on the right, on the bottom here? And I'm saying, okay, it's going to need a -3 on the top and a -3 on the bottom. So if I multiply by that clever one there, I should get -6, and then my -3 times 5 minus x. And then for the thing on the right, it's just going to remain whatever it was. So it's just going to remain the 1 here. So plus 1. And so now together, that gives me -5 all divided by my -3 times 5 minus x. And then I've still got my stuff on the top here, which I haven't needed to do anything with, which is pretty nice. I like that. And now when I'm dividing two fractions, I'm going to flip the denominator and then multiply these two things. So when I look at this, I look at it saying, okay, well, I'm going to have 4 over 5 minus x. And I'm going to wrap this in parentheses just so it helps to visualize it. And I'm going to say times, and now I've got my -3, 5 minus x on top. And I've got my -5 on the bottom. If you want to cancel off the negatives here, like if you just wanted to call this +5 and then +3, that would have been fine as well. I just left it because I knew we were going to be multiplying later anyways. So here I look at this thing, I say, okay, well, what's going to happen? Now's the fun part. I get to start crossing these things off. So these are gone. And now I'm left with 4 times -3, which is -12, divided by -5, which is really 12/5. And I'm good to go. Any questions on this one? Perfect. Going on to number 31 now. Here we want to solve the equation, and we always want to check our solution. So as I look at this thing, I think about what are my denominators. So for the first one here, I don't see a denominator. Just means my denominator is 1. For my second term here, my denominator here looks like x minus 3. So far, and we don't write the 1. I mean, you can write the 1 just for illustrative purposes with the colors here, but I'm now multiplying the 1 and the x minus 3 together, which really just is the x minus 3, for my common denominator between these two things. And I also want to look at what it would take to have a common denominator with this x squared minus 9, which this factors into x plus 3 and x minus 3. That's an x, I promise. There we go. And so when I see this, I need both of these. I already have an x minus 3, so I'm going to include my x plus 3. And now this ends up being my lowest common denominator for all of these things. So I'm just going to write this as my x squared minus 9. You can leave it written as x minus 3, x plus 3 if you want. Typically, I'd write it like that, but it is this, just FYI, so you guys know. So basically what I'm going to be doing is if I want to eliminate all of my denominators, which I would love to do, I'm going to multiply my entire equation by x squared minus 9. I'm going to do this on both sides. So I do it on the left and the right. Just multiply by this x squared minus 9. If you want to write it as x plus 3, x minus 3, you are more than welcome to. When I do that, the 1 in my denominator just means basically whatever I'm multiplying. There's nothing I got to cancel off. So this x squared minus 9 times 1 is just going to be x squared minus 9. And then I'm going to say plus 3 times whatever's left after I cancel off. So I'm going to cancel off with the x minus 3 right here, but I'm still left with an x plus 3. And then for the last term here, my 4, it is going to fully cancel off. X squared minus 9 cancels off with the x squared minus 9. I'm going to do a little bit of distribution here. So this turns into x squared. This becomes positive 3x. Here I get plus 9, which cancels off with my negative 9, equals 4. I'm trying to solve this thing, so I'm going to get everything on the same side, and so it's set to 0. So I get x squared plus 3x minus 4 equals 0. I see this thing, and I think to myself, well, maybe I can factor it, and if not, I'm going to move to my quadratic equation. And so I look at this thing, and I say, okay, 4 could be 1 and 4 or 2 and 2. If I had a positive 4 and a negative 1, it would give me my positive 3 in the middle. So this thing is going to factor nicely. So that 12 seconds I spent factoring was worth it. X plus 4, x minus 1 equals 0. I get 2 possible answers for my x values. I could get x is negative 4, or I could get x as positive 1. Now, I want to be careful. I want to plug this back into my equation to see that it works, okay? So let's start with the negative 4. With the negative 4, when I plug that in, I have 1 plus 3 divided by negative 7. So I'm going to say 1 plus negative 3 over 7. I could have just done minus 3 over 7, whatever, equals, and now on the right side here, I got my x squared, which is 16. 16 minus 9 is 7. 4 over 7. And this 1 is really 7 over 7. So I get 4 sevenths equals 4 sevenths, and everything is right in the world. Perfect. So negative 4 works. We just checked it. We go through and check 1. Spoiler alert, it works. When I go through and check 1, here I get 1 plus 3 over, now this will become negative 2. So let's pick another color here. 1 plus 3 over negative 2 equals 4 over, now 1 squared is 1, so 1 minus 9 is negative 8. This thing on the right simplifies to be negative 1/2. And over here I have 1, which is 2 over 2. So I get 2 plus, or excuse me, well, plus a negative, 2 minus 3, which is negative 1. So I get negative 1/2. And we see that all is right and well in the world there as well. So both of these solutions, negative 4 and 1, are real solutions for our equation. Any questions on this one? Perfect.